Chapter 13, 13.2 Independence and the Multiplication Rule. First, understand the independent events. Two events A and B are independent if knowing that one occurs does not change the probability that the other occurs. Let me explain this. Here you see there are 5 balls in a can. The 3 yellow and 2 greens. I take one ball randomly from the first can. Suppose it is a yellow ball. Now, what do you see after you have one in your hand? You see the second gulp, this one, right? Now you see this. Now you have 2 yellow and 2 green. Now go back to the first one. So what is the probability here for having yellow color ball? It is, I can say it is how many total? 5, and we had 3 balls. And what is the probability having the green color? 2 out of 5, right? For the green color, it should be 2 out of 5. Now you see we have only 4 balls because you have one in your hand. Now I am going to take one again from this without putting first one back. It means without replacement. So now how many balls we have? There are 4 balls. What are the probabilities? For the yellow one, we have only 2 now, right? Because one is in your hand, and total now 4. And similarly, the green one also 2 over 4. Now you see, first try and second try probabilities are different. Now you have green one in your hand. Now what do you see? You see this can now, right? So now you have only 3 balls here and 1 green and 2 yellows. So when we do this one without replacement, right, it means without putting it back, how many times you can do more? Only 3 times. Then you understand here, second try depend on the first try. Because first time you had yellow one, therefore second time you have only 2 yellows. If you had first time green, then second try here you will have 1 green and 3 yellow. Second try depend on the first one, and third one depend on the second one, and also definitely first one. So this type of events are called dependent events. They are not independent. What I do here, I take one, right? Then I put it back. I take one, suppose you took green, but I put it back. Here I put it back. Okay. So then, do you see any difference between first and second cans? No. First one you had 5 and second one also 5. Because we put it back with replacement. So if you can go to the third try, it is also the same. You can do this infinitely many times, it never change. So this type of events are called the independent events. Here we explain multiplication rule for independent events. If A and B are independent, probability A and B equal probability of A times probability of B. You can write this one with notation A and B equal probability of A times probability of B. So this can be used if and only if A and B are independent. Right, let me explain how to use this. go to the example 5. During World War II, the British found that the probability of a bombers being lost through enemy action on a mission or occupied Europe was 0.05. The probability that the bomber returned safely from a mission was therefore 0.95. It is reasonable to assume that missions were independent. Take AI to be the event that the bomber survived its eighth mission. For the first one, what is the probability of surviving two missions? Okay, AI is the eighth mission, so I can write two missions, A1 first mission and A2. That is missions bomber survived, right? Then, according to number 1 here, what is the probability of surviving two missions? That means he survived from the first mission and also from the second mission. Probability A1 and A2. And you see the key factor here. What is that? Missions were independent. If you don't see this part independent, then you cannot use this equation, multiplication rule. Now I am going to apply the multiplication rule because of this word independent. Therefore, this equal probability of A1 times probability of A2. So this is, you know, the probability is 0.05, 0.05, then time 0.05. So you can write this is 0.05 power 2. That is the probability of surviving two missions. Now let me explain number 2. What is the probability of surviving three missions? Yes, I think you understand now. He survived first mission and second mission and third mission. Again, they are independent. If we don't know if they are independent, then we cannot use this equation, multiplication rule. So we can use here probability of A1, probability of A2, probability of A3. So you know we can multiply 0.05, 0.05, 0.05. That is 0.05 to power 3. Then third one. In 1941, the tour of duty for an airman was established as 30 missions. What is the probability of surviving 30 missions? I think now you understand the order for this problem, but 30 mission, A1 survive and second mission survive and so on. The A29 survive and the 30th. Then you can write this because of independent probability of A1 time probability of A2, probability of A29 time probability of A30. You just multiply. Then you know 0.05 time 0.05, like that how many times? 30.